Welcome, everybody. My name is Ethan Knight with Western Water Assessment here at the University of Colorado Boulder. Thank you for joining us today. We are continuing our webinar series. In today's webinar, we will learn about the draft water chapter of the 5th National Climate Assessment from chapter lead, WWA's Liz Payton, who will present highlights from the chapter, followed by Q&A with members of the chapter author team. Next slide. So before we get started, I want to share a bit about Western Water Assessment for those of you who have not worked with us in the past. Western Water Assessment is an applied research program that addresses societal vulnerabilities to climate variability and climate change, particularly those related to water resources. We are based at the University of Colorado Boulder, University of Utah, and the University of Wyoming, and we work across the Intermountain West, or Colorado, Utah, and Wyoming. Western Water Assessment is one of 11 teams in the NOAA Climate Adaptation Partnerships, or CAP program, formerly known as the Regional Integrated Sciences and Assessments, or RISA program. Today's presentation will be recorded and last about 20 minutes, followed by Q&A with Liz and members of the chapter author team. Please feel free to submit questions via the Q&A window at the bottom of your screen. We'll be sure to share a link to the recording with you once it's up on our website. And I'm going to hand it off to Liz. Thanks.
Thanks, Ethan. I'm Liz Payton with Western Water Assessment, and I'm speaking for myself and not on behalf of the larger NCA project or the USGCRP. In this presentation, I'll give you an overview of the NCA and the draft water chapter, and then we will take some time for Q&A with members of the author team, as Ethan just described. So what is the National Climate Assessment? The U.S. Global Change Research Program, or USGCRP, was mandated by Congress in the Global Change Research Act of 1990. One of the responsibilities of the USGCRP is to deliver the quadrennial National Climate Assessment. The assessment is required to offer analyses of current climate trends and projections, as well as the impacts on human and natural systems. To date, the USGCRP has published 4 national climate assessments. The previous NCA, the NCA-4, was released in 2018 in 2 volumes. The NCA-5 will be a single volume. And here is the NCA-5 timeline, showing work that is finished on the bottom, this bottom row, and work yet to be done on the top row. And we are at the public and peer review stage that I've highlighted here in red. This chapter team has been working on the assessment since the summer of 2021, and we are now at the point of showing you what we've developed and asking you for your input. Public comment on the draft assessment and peer review conducted by the National Academies began in November and will close on January 27th, so just a couple of weeks. The NCA-5 has a similar table of contents as the NCA-4 with the addition of a few more chapters highlighted with the circles on the slide. An important new feature is the cross-cutting topic boxes on the right, these boxes here. The water chapter provided authors to the compound extreme events topic box and the COVID-19 topic box. Water is one of 32 chapters, and each chapter has a word count limit. For example, our chapter is limited to 5,000 words or about 10 pages of text. So throughout the NCA, there is a lot of cross-referencing and reliance on other chapters to make sure that topics get covered. That's particularly important for the water chapter because water is a big topic. It touches on almost all aspects of climate change. Addressing the nation's water resources in 5,000 words is challenging. So rather than a very shallow treatment of dozens of topics, we focus on a handful of big issues and point to other chapters that dig a little deeper into some of the other topics like energy, ecosystems, and agriculture. This is our brilliant chapter team. In the leadership, we have a group of people who help us communicate with the USGCRP and coordinate with other chapters and with the figure and data teams. Ariane Pinson with the Army Corps is our coordinating lead author and ensures that our chapter is coordinated with the other chapters. Drew Story Katya Kantar, and Yishin Lee are or were all points of contact between our author team and the NCA leadership. Then we have 10 authors bringing expertise from across the country in most areas of water resources, from universities and federal, local, state, and private agencies. Teruso Asefa, who is with Tampa Bay Water, which is facing multiple compound climate change challenges, is here with us today. Laura Condon is a groundwater expert at the University of Arizona. Leslie Ann Dupini-Giroux is at the University of Vermont and is the Vermont State climatologist. Ben Harding with Linker Technologies is an expert in long-range water resources planning, and he is here with us today. Julie Kiang is the Deputy Director of the Northeast region of the USGS and is also with us today. Debbie Lee runs the NOAA Great Lakes Environmental Research Laboratory and leads several initiatives around water quality. Steph McAfee with the University of Nevada at Reno is also the Nevada State climatologist. Justin Flug is at the Earth System Science Interdisciplinary Center at the University of Maryland, and he is a snow expert. Heather Tanana is with the University of Utah Law School and is an expert on tribal and indigenous water issues, and she's with us today. And Dan Wright, who is at the University of Wisconsin, is an expert on flooding and climate change. We also have two technical contributors, Imtiaz Rangwala and Francis Davenport, who are helping us on specific technical projects. Since this is a draft, it will likely change. So what I'm showing you today is not final by any means. Like all the other chapters, the draft chapter itself begins with a brief introduction, highlighting some of the data and research into climate change. This figure is from NOAA NCEI and shows how the number of large water-related disasters have increased over the past 40 years due to increases in exposure, vulnerability, and frequency of extremes. This figure goes through 2021, but the final report will likely have a chart updated through 2022, and so will include last year's Kentucky and Missouri flooding, among other events. Credits for this and other figures throughout this presentation are in the figure captions in the draft chapter. The water-related threats from climate change are not just about extremes in water quantity. Water quality is also expected to degrade under climate change due to multiple processes. Changes in ambient temperature, sea level rise, and changes in rainfall averages and extremes all have cascading effects on water quality. Like the other chapters, after the introduction, the water chapter is organized into key messages, with each key message followed by text to elaborate on and support those messages. The first key message is about the water cycle, and I will give you a minute to read it instead of reading it to you.
Mm-hmm.
Water cycle trends and projections fall under this key message. Here you see projections for mid-century for two of the hydrologic variables that we discuss, annual precipitation and annual peak snowpack. These projections were produced by Imtiaz Rangwala, one of our technical contributors, and the data set he used is described on the left. The wettest and the driest 20% of projections show the range of the CMIP5 models. And for comparison and consistency, maps are from the same data sets. Note that these figures show projected changes in inches. So in the Southwest, a half-inch change in annual precipitation is more significant to the region's hydrology than it is to the Northeast. Groundwater projections are not in this data set, but current trends show reduced recharge and increased pumping, and that trend is expected to continue. Excuse me. This slide shows summer soil moisture and evapotranspiration projections from the same data set. All right. So soil moisture on the left is essential for water supply, agriculture, and ecosystems, and is projected to decrease during the summer months, June, July, and August for most of the country. Exceptions include portions of the upper Midwest and Alaska. Actual evapotranspiration, which is limited by water availability, is expected to decrease in regions with decreasing or unchanging precipitation, such as the US Southwest, Texas, and the Caribbean. And that's this figure on the right. Wetter regions, including the Northwest, Alaska, and eastern parts of the continental US, are projected to have higher actual evapotranspiration. Let's see. Finally, runoff, sorry. Projections of annual runoff vary geographically depending on relative changes to precipitation, evapotranspiration, snow and ice, and soil moisture and groundwater. And the figure shows that decreases in runoff are projected in many parts of the nation supplied by snow and glacier melt. Decreases are also projected for Hawaii, while increases are expected for most of Alaska. And because we have such a limited word count, we rely on figures and content in other chapters, as I mentioned before. In our chapter, under this first key message, we point readers to this figure showing snowpack trends in the indicators appendix. The indicators appendix of the final published NCA 5 will be a wonderful resource if you are looking for climate change related trends. This figure shows declining trends in April 1 SWE, timing of snowpack peak, and length of the snowpack season. The trends and projections focus on changes in average annual or seasonal values, but we know that we can expect increases in the intensity of extreme events also. Extreme precipitation events are expected to increase in frequency and intensity, but those increases don't necessarily translate into increased frequency and intensity of flooding. Local flooding is a complex process affected by the landscape as well as the atmosphere. So will depend on land use changes as well as climate change impacts to watersheds such as wildfire and snowpack. This figure shows the complex interactions among extreme rainfall, soil moisture, snowpack, and snowmelt conditions. Climatic water deficit, or drying, is expected to increase with the warming atmosphere. The water deficit shown here is the shortage to potential evapotranspiration, or the evapotranspiration that would occur with unlimited water availability. The climatic water deficit is expected to increase across much of the nation as temperatures drive increases in potential ET without compensating increases in precipitation. The projections on the previous slide are in line with historical trends in the SPEI, or Standardized Precipitation Evapotranspiration Drought Index. This figure is one of those figures in the indicators appendix that we point to from our chapter. Our second key message is about impacts of climate change. And again, I'll give you a second to read it rather than reading it to you. One of the rising risks in this second key message is the impact of flooding. Francis Davenport developed this analysis and figure of flood damages due to changes in precipitation through 2017. And we brought her on board as a technical contributor for our chapter to extend her analysis to 2021. The figure shows cumulative observed inland flood damages across the contiguous US in gray, and the estimated portion due to precipitation change in green. Roughly 20 to 46% of increases in observed flood damages can be attributed to upward trends in precipitation. Climate change creates unequal burdens on people and communities. Losses from flood events are not distributed equally, as the figure shows. Losses are projected to increase in Black neighborhoods relative to the national average. And people who live along coasts, rivers, and in inner cities, or who work in agriculture and fisheries, have increased exposure to water-related hazards. And children, marginalized groups, and residents of low-income neighborhoods and rural areas are at greatest risk of exposure to pathogens and pollutants from climate change-driven impacts to water quality. Additional impacts to tribal and indigenous communities include displacement from lands with cultural significance. Under this key message, we also discuss the types of drought, the role that temperature can play in driving drought, and impacts from drought on groundwater, water quality, and agricultural losses. However, our drought figure is temporarily replaced in the draft with a gray box. The gray boxes throughout this draft of the NCA 5 represent figures or photos that we would like to use, but that can't be released yet because the copyright, hasn't been resolved yet. In another figure that still has an unresolved copyright, we highlight tribal and indigenous peoples' widespread lack of adequate water infrastructure and expect climate change to make those deficiencies even more dangerous. Our last key message is about adaptation to climate change. I'll give you a second to read it. Oops, sorry, I got to go back. I've got some text here. Under this key message, we make the point that climate change is overtaking the speed of policymaking, citing slow revisions of design standards for drainage and flood protection, competing interests in regulations and codes, and outdated metrics. The slow uptake of climate projection information in planning is due in part to the relatively coarse resolution of the information, the expense of tools and techniques, and the lack of standardization, and the wide range of possible futures presented by projections. And we write about how natural variability influences policy. This figure shows historical and reconstructed tree ring time series of Colorado River stream flows, illustrating the natural variability in basin hydrology, and places a couple of policy decisions in that context. The two events are the Colorado River Compact negotiations and the Colorado River Shortage Guideline negotiations. This last key message section ends with a discussion of the progress and gaps in the quality and usability of climate information, with some specifics about the information needs of tribal and indigenous communities in order to develop their own climate action and resilience plans. Our chapter contains 3 short call-out boxes providing case studies. The first is an account of how the complex interactions of water rights, storage, and water supply played out during the 2015 snow drought in Washington and California. It shows that the combination of the type of drought and the type of water rights held by users determined how well they fared. The second call-out box highlights the inequities that were suffered during and after Hurricane Harvey, the climate change component of that event, and the impacts to properties outside the 100-year floodplain. The photo we want to include here is still being reviewed by copyright, so that's why you see this gray box. The third call-out box offers an example of cross-border cooperation between Canada and the US over flood and water quality planning for operations on the Great Lakes. So that wraps up my overview of the chapter, and I'll talk a bit now about how to submit comments on the chapter. Your comments would be very much appreciated, but please don't send them to us directly. They need to go through the USGCRP system. So some of the things we want to know from you are, is the science accurately represented? Is the text clear to understand? Are the figures effective at communicating the science? Does this meet the needs of your community? And what should authors consider prioritizing or deprioritizing? So we would love to hear from you. And it's there are 2 more weeks to submit comments. And here's the URL, review.globalchange.gov, and the QR code will take you to that page. And I think Ethan has the link. On this page, you'll create a new account if you don't already have one. So you need to see where this red arrow is. It says create new account. That's where you are, need to be. Okay, let's see what's going on there. Sorry, just a second, I lost my, I'm here, just a second. I must have clicked on the wrong thing. Anyway, okay, so how do you submit a comment? Okay, once you have created an account, log in and look for the link on the document here where this red arrow is. So that's the next page. If you click on that, it will bring up a page that has links to all the chapters or the full NCA 5 draft if you want. And I hope that's helpful. And remember that January 27th is the last day to comment. And that wraps up my presentation, except for this announcement. If you are an artist or know some artists, you may be interested in this call for artwork to include in the assessment. There will be prizes. The top 2 finalists in the adult category will receive $1,000 and $600. And the top 2 finalists in the youth category, age 13 to 17, will receive $200 each. And that's it. Thank you. And I'll turn it back to Ethan for Q&A.
Right. Thanks so much for the great presentation, Liz. That was great. I see a couple questions. Get that up here. Okay. So this question that's in so far, see if I can paraphrase it. I guess it's saying that the report presents results of RCP 4.5, and there's no explanation for why this single RCP was considered. Is that the case, or you know, why? Maybe some reasoning behind?
Yeah, that's a really good question, and I think Ben is the best person probably to call on to answer that question.
I'll do my best, Liz. First of all, let me just say I'm a water resources engineer, not a climate scientist. So with that limitation, let me say that the RCP 4.5 is an intermediate scenario, halfway, sort of roughly, well, in between, not halfway, between the best and worst cases that people anticipate. But stepping up just one level, let me say that most of the National Climate Assessment uses projections from what's called the CMIP-6 archive or ensemble, which is the most recent set of modeling results. But unfortunately, the hydrology modeling that was necessary for us to present our results, such as runoff and evapotranspiration, effects on the climate water deficit, soil moisture, and all that, have not been done on the CMIP-6 ensemble. So we were forced to rely on the CMIP-5 ensemble. And that's where the RCP 4.5 comes from. It's called a representative concentration pathway. And it's a terminology used in CMIP-5. And in CMIP-6, it's called the SSP shared socioeconomic pathway, again, with 4.5. And those two numbers, 4.5, represent the increased radiant flux onto the surface of the Earth. That is the amount of increased thermal radiation that comes down to the Earth's surface in watts per square meter. So it's a very small number, 4.5 watts per square meter. These scenarios range from now, I think 1.9 is the lowest to 8.5 is the highest. And again, all of those represent this increase in radiant energy. So you can see that 4.5 is roughly halfway in terms of radiation, net radiation between the lowest and the highest cases. Other chapters have used different indices in order to select what level of global warming level they're going to use, but they're all fairly consistent with using this RCP 4.5. And I should say that the effects of climate change that have been projected and that we've presented in here are dependent on two things. One is this selection of the forcing scenario, and second is the time frame that we're using. And they vary across the chapters, but are relatively consistent on a time frame that represents the middle of the century, which is what we've done. I hope that was helpful, and if not, I'll follow up.
Yeah, if the person who had the question, you can maybe unmute. Can he do that, or she?
I don't think so.
Okay, well, maybe they can follow up with more questions, though.
Yeah.
Thank you, Ben.
Oh, I think I answered the next one.
Yeah. I was just going to ask, but I think you answered it. So
can you ask it? I don't know what it is. Just so that just read it so that we know what it is.
Yeah, I'll just do that. So in line with why RCP 4.5 was selected, why was CMIP 5 used over CMIP 6?
Oh yeah. So yeah.
And again, it's because we didn't have the hydrology modeling. Let me just say that the climate models project consequences in the future for all sorts of things: atmospheric conditions, ocean conditions, and land surface conditions. But in order to get good estimates of the hydrology, we need to do separate standalone hydrology modeling because the scale of the climate models are so large necessarily in order to be able to make the runs occur fast enough. So we do offline hydrology modeling at a smaller scale. And that hasn't been done yet for CMIP 6, or it might be done now. I haven't checked recently, but it wasn't available at the time we had to formulate our chapter.
Thanks.
If I could
yes,
add
please.
quickly on that one as well, along what Ben said, I think the water chapter, as Liz showed, it's really broad in geography covering it. And we recognize that in some places that there are multiple climate outlook, multiple results, and so on. But the intent here is to cover the entire US. And again, goes back to what Ben just said. I think that's another issue we face given the 10-page limitation, and then also what can be presented. You have to cover the entire US. Otherwise, I agree with the prior comment that indeed, typically we look at a range of scenarios and look at to come up with some envelope for decision making.
Thanks, Teresa. And Teresa, I wonder, just because we have a fair amount of time for questions, if you could talk a little bit, if I don't want to put you on the spot, so if you don't want to, it's okay. But about sort of the local challenges of using these projections, because being at Tampa Bay Water, I know that that's a big issue for you, and trying to understand, and sort of project what's going to happen for planning.
Yeah, so this is great. So when I was looking at some of the figures, even you presented to them, you can see how, reaction or some result from Florida is mentioned. So this analysis by necessity, they have to use some tools that are applicable for the entire US geographic area. What we found, even when you get into hydrology, we have a little bit different than I'm talking about more coastal Florida and a little bit for the Southeast as well, that this dynamic interaction between surface water and groundwater and the close groundwater levels and are typically not included on regional or continental scale hydrology that we typically use to produce these maps covering the whole United States. So that's an issue. And the other is places like Florida. Obviously, you have completely different impact in terms of your local, whether it's convective and even other processes that, for example, the current, the loop current, they call it in the south of Florida, that kind of local impact for climate, they don't even exist in this CMM5 and or SSPs and all on those. So typically you would go to regional scale modeling to capture those because they just don't exist. In fact, well, we came a long way. It's great what we have today. 30 years ago, 20 years ago, Florida didn't even exist. So we are happy now Florida exists and we have some data, but still there are quite important climate, local climate that are not represented by these big scales. So there is hydrology, there is climate, and most of the models that try to capture using continental scale hydrologic models, they tend to not really represent the reality, let's put it that way. And that's always a challenge. Maybe in the future, if there is some way of compiling all these results with local and then coming up with some big picture, that's possible. But on the other side, we want a study like this to provide guidance on policies and so on. So you want to have it that breadth and covering a range of areas. So yeah, Florida has its own challenge. But for this purpose, we have to focus on the national level result as well.
Great.
Both in hydrology and climate. That's always a challenge for us.
Yeah. And there is a regional chapter that covers the Southeast.
Yes.
So people can, and that has double the word count that we have. And so they can dive into things a little bit more deeply, especially because they have a more limited geographic range. So people who are interested can go and read download and read the Southeast chapter also. Thanks.
Great, thank you. And I see a raised hand, actually. I think I can allow people to talk, so.
Oh, good.
Jesse Webb. You can talk now, Jesse, if you'd like. Maybe not. Well, in the meantime, I'll move on to the next question.
Okay.
Let's see. So this question says, the report does neither present temperatures nor Pacific oscillation impacts to the extreme events as the main drivers. Is there a particular reason why that's true? Or?
Yeah, right. No, that's a really good question. And if we had space, we would cover a lot more stuff, but there is a chapter devoted to physical processes, and there's a chapter devoted to climate trends. And the physical processes and climate trends chapters have a lot of information about that level of change, the sort of atmospheric circulation information, that kind of thing. So I would direct you to those. And if they still don't answer your questions or provide you with enough information, then please submit a comment that you're still looking for answers to your questions and you're not finding them. So I hope that's helpful.
Great. All right. So this next question says, following on the RCP 4.5 question, why was RCP 8.5 not used?
Yeah, well, we wanted to use what we thought was the most reasonable sort of, we had two sets of these hydrologic variables, the one from CMIP5 4.5 and one from the CMIP5 8.5 scenarios. And so we chose the 4.5. If we had more room, we would do the 8.5 too. We had to pick one, and it seemed like the most sort of closest to the probable future. But, if you think 8.5 would be a better scenario to choose, please make a comment about that, because we will look at it for sure.
Hey, Liz, can I add a little bit to that?
Yes.
The other chapters talk a little bit about the RCPs, or the shared socioeconomic pathways, and it isn't really, the evidence indicates that we aren't necessarily on a path to 8.5 because of more advanced uptake of technology and things like that. So I think it's, you know, it's not, if we had room, I guess we could answer almost every question we get by just saying 5,000 words. That's what we have, and a limited number of figures. But yes, it would have been better to be able to show a broader range of possible futures. But space limited us to what we had. And I always like to point out that there's enough bad news to go around in the climate change business. And sometimes showing just the extreme, if we had a choice, can lead people to basically a view of despair.
Thank you, Ben.
Great. Thank you, Ben. So I actually got a couple here by email. So this question is, why are there no error bars for the natural flow at Liz Ferry graph?
Those are actual observations, so they're not projections. Or, yeah, so I don't know why you would use error bars, but maybe Ben, do you think there's a?
What, would you read that again? Because I couldn't quite hear it.
Yeah, sorry. So why are there no error bars for the natural flow at Liz Ferry graph?
Well, you know, in principle, there would be a confidence interval in those, because they are what are called observations, but every observation has its own uncertainty. But that's not generally the practice, and it complicates the chart, makes it harder for people to understand. There would be broader error bars on the reconstructions that go back to what did they go back to? I think 1200. I can't remember without looking at the chart myself. But they just make the chart really a lot harder to see, and kind of, you know, just obscure the points we're trying to make. There are several important points on that chart that we're trying to make, and the most important, the most direct one, was how the hydrology in sort of recent past affects people's view of abundance or lack thereof, and thus affects policy. And that's why we showed this particular chart in principle. Also, it illustrates how natural variability manifests in both space and time. So you can see how parts of the country were wetter while the Colorado River was drier, and so on, and vice versa. As the primary point was to show that this relative period of relative abundance, which was one of the wettest periods in 600 years, or 800 years, caused an exuberance, if you will, in terms of allocating water on the Colorado River, which has come back to haunt us now as flows revert back to the mean, the long-term mean, and below, and are projected to go below for climate change.
Thanks.
So if I could just add quickly, I'm Julie King, I'm with USGS, and so the data is from USGS, at least in part, the natural flows is. I'm sorry, anyway, the gauge flows would be from USGS.
Right.
And so our current practice is not to provide uncertainty estimates for our stream flow information, but we're working on developing quantitative estimates of uncertainty, because we do recognize that it's important that we know that our stream flow records are not perfect, and we want to be able to, in the future, give well-reasoned estimates of what the uncertainty in our stream flow information is. So we're working on it, but we're not there yet.
That's awesome, Julie. Thank you so much.
Thank you. And I see a raised hand now, so I'm going to allow George to talk here.
Can you guys hear me?
Yeah.
Yeah. So actually what you said was actually not correct. You're saying, well, you don't show the error bars because it complicates the graph. What the lady from USGS said is correct, but also incorrect. First of all, the natural stream flows are calculated by reclamation, not USGS. And reclamation does not provide error bars. So there actually are no error bars, which means we don't know what the uncertainty in the water supply is currently, because we have a number quoted to 7 significant figures, but we don't know what the uncertainty is. Secondly, the statement, I think, is, and I appreciate you're not doing anything unusual. You're doing what everyone does. So I'm not accusing you. That's your job, is to represent what everyone does. But what everyone's doing is wrong. And they're saying that in the compact was 1922, the river flows were large. Therefore, it's understandable that the river was allocated. No, there was only 10 years of data. So it was the uncertainty in the long-term flow was enormous in 1922, but no one took that into account. So what you knew for sure in 1922 was that the flows lay somewhere between 12 and 22 million acre feet. But that was hidden by saying we're going to take the average, which is exactly what you're doing, with no errors. And as long as we keep repeating that, we're doomed. And the fact that USGS says, 100 years into this game, we're thinking of calculating error bars. It's a bit late now when the system is collapsing. Lake Powell is 30 feet away from not producing any electricity, and the native communities, as you've pointed out, are under immediate threat. It's an existential threat here in Powell to the Navajo Reservation. I'm not blaming you for any of this, but I think your answers respectfully, I'm not an expert, were a bit misleading. If you're not doing error bars, you're hiding the risk. The risk is in the error bars, in the exposure. I think you know this. USBR needs to publish error bars. This is a bit of a rant rather than a question, but a respectful disagreement.
Thank you.
Your opinion. But I appreciate the work you do, and thanks for letting me speak.
Thanks.
Let me first apologize for taking credit for what reclamation does. So the natural flows, yes, you're right. Those are reconstructions, but the gauge flows do come into play there. And so that's what I was responding to. And I think you're absolutely right. We need to get our game together and put out the uncertainty estimates. I think there's also a difference between putting the uncertainty on our individual, the values of streamflow for any particular day, and understanding what the uncertainty is for a long-term statistic, such as mean annual flow, based on how you calculate it. And so that's another thing that we work on, and we're trying to incorporate that into reports that we put out about the long-term statistics.
Thanks, Julie. Also, that section of the chapter is really about how the natural variability influences policy. So the sort of red light, green light effect of when you're in a drought, you're all worked up and ready to plan for drought. When you're in a wetter period, you can relax a little bit about drought. Maybe you're planning for flood. And it's just this sort of how the long-term view gets lost based on what the current conditions are. So that really was the point of that. And maybe we need to make that a little more clear. Thank you. What else do we have, Ethan?
Let's see. Thank you, George. So this next question says, you mentioned how low-income and minority populations are disproportionately affected by disruptive flooding. Do you provide guidance on how to level the playing field?
No, we don't actually offer recommendations, and that's not part of the NCA's mission. It's really to lay out sort of what the current science is about climate change. And but I do want to turn it over. Maybe Heather has some ideas about how to answer this question.
Yeah, I mean, it is challenging because the role of the report is not to make recommendations, to not engage in advocacy. We're really trying to take what available research is out there and present the most current up-to-date information so that then people who read the report can utilize it perhaps in your own advocacy work or engagement. And so the things that I think we do include and that are included in other chapters, like the Tribes and Indigenous Peoples chapter, are highlighting, like especially their chapter highlights the value of Indigenous science and traditional ecological knowledge. And then similarly in our chapter, we talk about barriers to decision-making of communities over issues that impact them, relate to their water management. So I think you can take some of those and you know, if you read it, extrapolate it to, even though we don't articulate it, right? Communities need more data if they're going to engage in decision makings about their communities, things like that, I think will be helpful to people, hopefully.
Right. That's a great answer. I mean, we do lay out what the barriers are, what the data needs are. And hopefully, like Heather said, people can pick up on that. That was a good question. Thank you.
Yeah, thank you, Heather. So we just got another question. Is there a chapter that discusses the relationship between weather risk and climate risk?
The chapter 3, I believe, which is the climate trends chapter, talks a lot about extremes, if that's what you're thinking. And they do have a lot more information about like heat extremes and frequency of extreme precipitation events and things like that. So I would look in that chapter, but if you don't find it, please send in the comments. So.
Great, thanks, Liz.
Sure.
Another question here. Let's see. How did you and the author team determine what topics to cover in the water chapter?
So we had several meetings where we actually used like dot storming, these different kinds of techniques to try to figure out what was important to our author team and what we thought was important to the readers. And we sort of narrowed it down from, I don't know, there must have been probably 30 ideas, something like that. And we narrowed it down to the handful that we ended up covering in the chapter. So it was very much based on the author team's individual experience and what and their areas of study and that kind of thing. Then we did have a public engagement, public outreach event where we presented our proposed outline to the public, and the public commented on that. And we made some revisions to our outline based on that to make sure that we did include actually areas that were important to the public.
Liz, and I just said that we also had a lot of meetings with the other chapters.
Yeah.
Everyone has space limitations to try and make sure that someone was covering a topic that was important if, say, we couldn't.
That's right. That's a good point.
And we also, at one of the earliest time, we want to make sure that not to repeat what was in NCA 4 as well. Mm-hmm. We looked at those.
Yeah, that's right. Well, NCA 4 devotes the water chapters, big chunk of the water chapters devoted to infrastructure. And so and not much has changed regarding infrastructure since then. So we did not devote a lot of text to that.
Liz, if I might just go back and flog this dead horse, but I think every one of us was frustrated by the limitation on our 5,000 word limitation, given that water, some people will say that climate change is water change. It touches every aspect, all the regions, every aspect of the economy and ecology. And yet we were limited to 5,000 words. And we would have liked to have had a much broader discussion of these issues.
Yeah, right. But like Heather said, we did try to talk to other chapters and make sure that the topics that we were not able to address did get addressed somewhere. So.
Great. All right. Well, I think that is it on the questions. So I think we can end early today. It was a great Q&A though. Thank you everybody for all of your wonderful insights and great questions.
Let's wait a minute and see if another question or two comes in, since we have like 10 more minutes. So sure. If that's okay with everybody. When we had our public engagement sessions last year, when we had our first outline, we had a lot of public comment on whether we were including tribal and indigenous people or not, and what the impacts were to them and how they were engaged and that kind of thing. And so we made sure that to cover that, though, like, you know, Heather wrote amazing text for us. And unfortunately, we had to cut so much of it. But anyway, Heather, I don't know if you want to talk about that for a minute. I mean, just water issues and tribal and indigenous communities and what's new and different. And
yeah, I think there's a big recognition across all the different chapters that indigenous peoples climate change is having very strong impacts and in different ways, and looking beyond our American Indian Alaska natives, but also to Native Hawaiians and the territories as well. And so we did, going back to kind of discussions, there was a concerted effort, I think this time around, to make sure that all the different indigenous peoples, not just tribal nations, were, and their, I don't know, like what's happening to their communities was included, as well as opportunity for individuals from those communities to also engage. There are several indigenous contributors, right? Myself, I'm a citizen of Navajo Nation, some of the leads of indigenous and other groups are involved, but we also wanted to make sure that outside of the chapter authors, that other community members were able to see the report and provide feedback as well. So yeah, so hopefully that's, you know, again, it's so hard with the limitations, and we include the study sites, so we can't, I saw there was a comment about wanting more about what the research we cite to, but we just don't have the space. So hopefully people look at the citations and then read the full reports and that research, and not just our report, but yeah, I think it's
right.
Hopefully it's improved upon the last round.
Yeah, thanks, Heather. Yeah, I think a lot of the comments that come in about what we should address, we probably agree with you, you know, but we couldn't do it. We just didn't have the space to do it. So thanks.
Yeah, thank you. There's one more question here.
Right.
So it says, I am looking for guidance on going from regional to local modeling of river flow. So I assume where can they find that?
I assume this would be like under climate change, maybe. I guess it would be, because they're using regional models, maybe. Okay.
Yeah, I'm not sure if we put at least a link, but this is one of the projects under the Water Utility Climate Alliance we have done some years ago. In fact, there was a real-time follow-up on exactly this, looking at how do you get from big picture to regional. And then we had 4 examples, and one in Pacific Northwest, and then I think San Francisco was there, and then from the East, Tampa Bay and New York, we end up producing a document. We call it co-production of actionable science. Basically, what says that report, I believe we may have some references here too, is basically how you would use regionalized climate projection and collaborate with the science for, kind of real feedback, and then produce a knowledge or an actionable science that decision maker can use. So we did document in that report as well, and then also what are the challenge for this. So that's one of the, I think, the project that we did with Water Utility Climate Alliance. I think if we haven't cite that, but I think you can find that specific document on the website as well.
Right. Yeah, the WUCA organization, right? Great.
Yes.
Yeah, that's fabulous. Thank you.
Great. Oh, they said, can you repeat the reference?
Can you, well, do you know the title of the document, Teresa?
Yeah, so it is actionable. Oh my God, let me just pull, and I don't think you can find it online. I was looking for that yesterday, somebody asked me, and let me try to quickly find my, if I can, my PDF. Let's see. Okay. When we need it, just a minute. I think I should find it here.
Yeah, no worries.
I have the copy, just somebody was asking me. Okay, it's here. So it says actionable science in practice. That's the main title. And then the subtitle is co-producing climate change information for water utilities vulnerability assessment. This is a project from 2015/16.
Thank you.
And there are also a peer review, a journal articles, I think in similar name, but that's what it is.
Great.
Actionable science in practice.
Thanks.
Great. Yeah, thank you.
Mm-hmm.
All right. We can wait 1 more minute here for questions.
So I really appreciate everybody who's attended and whoever watches the recording. And just let you know that if you do submit your comments, we will respond to them. So that's our charge. We are required to respond to all the comments. So we'd like to hear from you.
Yeah.
But if you ask us to add stuff, please ask us to remove stuff. Just it'd be good to know what the priority, if your priorities are off from our, different from ours or whatever.
Oh, I see a question here. When will the recording be up? Probably in the next couple of days. It takes a little bit after the Zoom is over, and then I put it on YouTube. So I will send an email to everybody who registered for this event, so you can watch it afterwards.
Thanks, Ethan.
Yeah. All right. Well, if there are no more questions, might be a good time to wrap it up. It's almost noon. Mountain time. But thank you again, Liz, for your awesome presentation, and also for the whole team here for helping answer questions, and very, very thoughtful answers. It was great. If we didn't get to your questions today for the audience, we'll make sure to send them via email, and you can keep the conversation going. And as I said, we'll be posting the recording of this webinar on our website, and I'll send you a link as well when that's posted. And in the meantime, feel free to reach out to us. You can reach out at wwa@colorado.edu, or you can email Liz at elizabeth.payton@colorado.edu. And the last thing I'll say is we developed a survey. It's only take a couple minutes of your time to gather feedback on our webinar, and it'd be very much appreciated if you could fill it out for us. So I will send that link in the chat here now. And I think that'll do it for today. So thank you everybody for joining, and I hope you have a good rest of your day.